Hello, everyone. Welcome to join me in this course. Today's topic is Fixture dynamic motion process and working logic. During robot programming and simulation, the fixture, as an essential part of the robot end effector, plays a crucial role in the robot's ability to complete various tasks. The correct setup of its dynamic motion and working logic is vital. In this lesson, we will cover three main aspects: basic fixture settings, dynamic motion settings for fixtures, and working logic settings for fixtures. By the end of this lesson, I hope that you will be proficient in importing and adjusting the basic settings of fixtures in the RoboGuide simulation software. This includes defining the coordinate system, setting the gripping force, and controlling the opening and closing of the grippers. Furthermore, I expect you to master the methods for setting the dynamic motion and working logic of fixtures in RoboGuide simulation. You should be able to configure appropriate fixture states, triggering conditions, and action sequences based on different task requirements. First, let's take a look at the basic settings of fixtures in the RoboGuide simulation. In the RoboGuide simulation software, we first need to create a system for the robot and copy the converted robot fixture CAD model to the simulation project folder that has been created. In the left-hand navigation tree, we need to right-click on the tooling option, then select Add Link and CAD File, CAD Library and Sequence. In the dialog box that appears for selecting the 3D model, choose the fixture and import it into the simulation software, as shown in the figure. After importing, we need to perform a series of settings and adjustments on the fixture to ensure that it can operate correctly in the simulation environment. These settings include defining the fixture's coordinate system, setting the gripping force, and controlling the opening and closing of the grippers. Through these settings, we can make the fixture exhibit dynamic characteristics in the simulation that are similar to those in the actual system. Next, let's learn about the dynamic motion settings of fixtures in the RoboGuide simulation software. In RoboGuide simulation, the dynamic motion settings of fixtures are primarily accomplished through the Simulation tab in the software. Within this tab, we can select different states of the fixture and set the motion parameters for the fixture under various states. Here are the detailed setting methods. 1. Fixture clamping state setting. First, we need to select the clamping state of the fixture. In the Simulation tab, choose the function as Material Handling Clamp, select the fixture model in the clamping state, and click Apply to apply the setting. At this point, the fixture should switch to the clamping state. To verify whether the fixture has successfully switched states, we can attempt to operate the robot to perform a clamping action and observe the motion of the fixture. 2. Fixture releasing state setting. After the fixture is in the clamping state, we also need to set the releasing state of the fixture. Similarly, in the Simulation tab, we select the releasing state of the fixture and click Apply to apply the setting. At this point, the fixture should switch to the releasing state, as shown in the figure. To verify whether the fixture has successfully switched states, we can attempt to operate the robot to perform a releasing action and observe the motion of the fixture. 3. Dynamic effect testing. After setting the clamping and releasing states of the fixture, we need to conduct dynamic effect testing. By operating the robot to perform clamping and releasing actions, we observe whether the motion process of the fixture is smooth and accurate. If any issues are detected, we need to promptly adjust the motion parameters of the fixture or check whether the fixture settings are correct. Lastly, we will introduce the working logic settings of fixtures in the RoboGuide simulation software. In RoboGuide simulation, the working logic settings of fixtures are crucial for ensuring that the robot can correctly execute clamping and releasing actions. By configuring the triggering conditions and action sequences for the fixture in different states, we can achieve complex clamping and releasing operations. 1. Trigger condition settings. Trigger conditions refer to the prerequisites for the robot to execute clamping or releasing actions. In RoboGuide simulation, we can set trigger conditions according to actual requirements. For example, the clamping action can be triggered when the robot detects that the workpiece has arrived at the specified position. The releasing action can be triggered when the robot detects that the workpiece has been clamped and moved to the specified position, etc. 2. Action sequence settings. The action sequence refers to the order in which the robot executes each step during clamping and releasing actions. In RoboGuide simulation, we can set the action sequence according to actual requirements. For example, the robot can first execute the clamping action, then the moving action, and finally the releasing action. By setting the action sequence reasonably, we can ensure that the robot can efficiently and accurately complete various tasks. In this lesson, we have gained an in-depth understanding of the dynamic motion process and working logic settings of fixtures in RoboGuide simulation. We have mastered how to import and adjust the basic settings of fixtures in the simulation software, as well as how to set the dynamic motion and working logic of fixtures. In practical applications, we need to set the appropriate fixture states, triggering conditions, and action sequences according to specific task requirements to ensure that the robot can efficiently and accurately complete various tasks. At the same time, we have also emphasized the importance of conducting thorough testing and validation during the simulation process to ensure the correctness and effectiveness of the settings. I hope that you can apply this knowledge to real-world projects and continuously improve your robot programming and simulation skills. Thank you all for your participation, and I look forward to seeing you again in the next lesson.